Hello and welcome back to geometry. Let's read section 3.2, angles and parallel lines together. Previously, we've named angle pairs formed by parallel lines and transversals in the previous lesson. So now we will use new theorems to determine the relationships between specific pairs of angles and use algebra to find those angle measurements. Why might this be useful? Well, those who work in construction and maintenance often use an access scaffold. This structure provides support and access to elevated areas. The transversal T shown provides structural support to the two parallel working areas, and maintaining those surfaces as parallel is critical to the scaffold functioning properly. Part 1, parallel lines and angle pairs. In the photo, line T is a transversal of lines A and B, and angles 1 and 2 are corresponding angles. Since lines A and B are parallel, there is a special relationship between corresponding angle pairs. You may have made this, predicted this yourself. So we call this the corresponding angles postulate. If two parallel lines are cut by a transversal, then each pair of corresponding angles is congruent. So here we've numbered our angles left to right, 1, 2, 3, 4, and then back 5, 6, 7, 8. We already know about any pairs within the intersection. Vertical angles are congruent and linear pairs are supplementary. But now we can go from one intersection to the other. Angles 1 and 3 are congruent. 2 and 4 are congruent. 5 and 7 are congruent, and 6 and 8 are congruent. We'll practice using that to solve for missing angles in example 1 in part 2 of the video. Now, in example 1, angle 2 and 5 are congruent alternate exterior angles. This and other examples suggest the following theorems about other angle pairs formed by two parallel lines cut by a transversal. We have three theorems here for three of our other angle pairs from transversals. First of all, alternate interior angles. If two parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent. I'm going to highlight this here in blue. The alternate interior angles are congruent. Next, consecutive interior angles. If two parallel lines are cut by a transversal, then each pair of consecutive interior angles is supplementary. So notice 1 and 2 are supplementary, 3 and 4 are supplementary. I like to imagine a series of streets where you have some parallel streets here. If you're driving down one street and you make a turn, and then you make another turn in the same direction, so let's say this would be from the perspective of the car, a left turn, followed by another left turn, onto a parallel road, you are now going exactly the opposite direction you were traveling. So you've turned effectively 180 degrees. That's how you can remember that these should be supplementary. And we'll highlight this one in red. Consecutive interior angles are supplementary. And finally, alternate exterior angles theorem. If two parallel lines are cut by a transversal, then each pair of alternate exterior angles is congruent. I'll go back to highlighting this one in blue. So notice that both types of alternate angles, both the interior and the exterior, are always forming congruent pairs. These theorems generalize the relationships between specific pairs of angles. If you get confused about them, you can verify them with the methods you used in example 1, using only corresponding, vertical, and supplementary angles. So with just those three angle pairs, you can always work out for yourself how these others must pair up. Now, since postulates are accepted without proof, you can use the corresponding angles postulate to prove each of the theorems above. This is effectively a generalized form of example 1. To prove the alternate interior angles theorem, we have to start with knowing that the two lines are parallel and that T is a transversal. When we're given those two things by the corresponding angles postulate, we can see the corresponding angles are congruent. So in this diagram as numbered, 2 is congruent to 4, and 6 is congruent to 8. Also, 5 is congruent to 2, and 8 is congruent to 3 because vertical angles are congruent. Now we know that 2 is congruent to 4. 2 is congruent to 4 by corresponding angles. I want to prove that 4 is congruent to 5. Well, I know that 2 is congruent to 5 and 4 is congruent to 2. So, since congruence, like equality, is transitive, therefore 5 is congruent to 4 and 3 is congruent to 6, since congruence of angles is transitive. We'll continue with example 2 in part 2 of the video. Now on to part 2 of the section. Algebra and angle measures. The special relationships between the angles formed by two parallel lines and a transversal can be used to find unknown values. We'll go through example 3 in depth in part 2, but real quick, take a peek. Notice that we have the same setup, two parallel lines, a transversal. We've numbered all 8 of the angles involved, and we are given some algebraic expressions for some of them. Since we know more pairs of congruent angles here, we can create more equations and then use those equations to solve for x. And you could, one step further, plug x back into those expressions to find the actual angle measures. Now, a special relationship occurs when the transversal of two parallel lines is a perpendicular line. In a plane, if a line is perpendicular to one of two parallel lines, then it is perpendicular to the other one. I bet if you thought about this for more than 5 seconds, you would agree it's fairly obvious. But we could prove this using our other angle theorems if we wanted to. Don't forget that this upside down capital T is read as line B is perpendicular to line T. That takes us to the check your understanding questions, so we have finished reading the section. So long, farewell, enjoy the rest of your day.